In this lesson, we'll go over adding and subtracting rational expressions. We'll review adding and subtracting fractions because what we know about adding and subtracting fractions relates to adding and subtracting rational expressions, and we'll apply that understanding, as I mentioned, to adding and subtracting rational expressions. So review. So fractions are equal parts of a whole. So for instance, if we talk about a hockey game, it's divided into 3 equal periods. Or if you talk about like a pizza slice, let's say it's divided into 4, because if I try to draw any more, it's going to get worse. If you eat 1/4 of the pizza, you're eating one of the parts of the whole that's divided up equally. Something else that's helpful to talk about is negative fractions and how to handle those. If the negative sign is out in front, it means you could put it with the numerator or with the denominator. All of these mean the same thing. The third one, with the negative in the denominator, is just a little bit more awkward. You don't see that very much, but it is technically correct. And so when we're dealing with rational expressions, let's say we have a negative out in front, what this means is that we could put it with the numerator. Now, if we put it with the numerator, it has to go to both parts. So this would be negative x plus 2 over x plus 1. You could also put it to the denominator by distributing as well, just like we did with the 2 over negative 3. Okay, and when we add and subtract fractions, we need common denominators, or finding the least common denominator, as you may have heard. So when you hear rational expressions, think of fractions. Technically, a rational expression is a polynomial over a polynomial, but the same concepts that we know when we work with fractions also apply to rational expressions, just like they do with multiplication and division of rational expressions. Example 1, perform the operation and simplify. So lots of negative numbers going on here, or lots of negative signs. Notice how the denominators are already the same, so we can go right to adding or subtracting these. What I'm going to deal with first, though, is the negative. So I'm going to distribute the negative to the numerator to write this as negative 5x minus 1 over 5x. And if I'm adding a negative instead of subtraction, this becomes positive, and the negative goes to the 4x and to the 11. And so now I can see what I'm working with because there's no more negative signs. This is equal to negative 5x minus 1 plus negative 4x plus 11 over 5x. So we add the numerators and keep the denominator the same. And then we combine our like terms, negative 9x minus 10 over 5x. Now I want to mention a couple things, and I'll write in red because these would be mistakes. The x's don't cancel because it doesn't come out of everything. Okay, if every term 9x, 10x, and 5x all had an x, then it could cancel. But they don't, so those do not cancel. Also, we can't reduce the 5 and the 10 because, again, 5 doesn't come out of 9. So if you're going to reduce or simplify, it needs to come out of every single thing in order to do that. So your final answer here is just negative 9x. Oh, this should be a positive 10. Positive 10 over 5x. Example 2, perform the operation and simplify. So in this case, our denominators are different. So we have to determine the least common denominator. We need to take into account the numbers, the 8 and the 6, and the x. When I look at least common denominator, sometimes I look at it in terms of what does one denominator have that the other one needs. Okay, so in this case, they both have an x, but the 6 and 8 are different. Between 6 and 8, they can both get to 24. Okay, so for negative 5 over 8x, I'm going to multiply this one by 3 over 3. And the reason why is 3 times 8x is 24x. For the fraction on the right, I'm going to multiply by 4 over 4. So let's see what we have. Negative 3 times negative 5 is negative 15. 3 times 8x is 24x. Plus 7 times 4 is 28 over 6x times 4 is 24x. So it's helpful to write that out too to make sure that your denominators are in fact the same. And so now we add. Negative 15 plus 28 is 13 over 24, and the x stays in the bottom. Perform the operation and simplify. Okay, so these denominators are totally different. When we're looking for least common denominator, we're looking at what can we multiply one by to get to the other. In this case, our least common denominator is just x plus 2 times x minus 1. The fraction on the left has the x plus 2. The fraction on the right needs it. Also, the fraction on the right has x minus 1. The fraction on the left needs it. So we multiply x minus 1 times x minus 1. So now we have 5 times x minus 1 over x minus 1, x plus 2, plus 6 times x plus 2 over x minus 1, x plus 2. Okay, now you distribute so you can see what we have, and then we'll combine like terms. So this is 5x minus 5, and I'm going to combine these all in the same step just so I don't run out of room. And then we keep going. And the last thing we do is we check to see if anything can factor and thus simplify further. This would stay as 11x plus 7 over x minus 1 times x plus 2. You can multiply out the denominator if you want. One isn't necessarily more simple than the other. If you were to multiply out the denominator, you would get x squared plus x minus 2. Between these two forms, x minus 1, x plus 2, and x squared plus x minus 2, one's not more simple than the other. This is more factored, or this is factored, but in terms of simplifying, you're trying to get it as small as it can go, and those are both the same. Last one, perform the operation and simplify. So in order to determine the common denominators, you want to make sure all your denominators are factored. So this is 9 times 2, x minus 2. Okay. So determining the least common denominator here, they both have an x minus 2, so that part is good to go. Notice the fraction on the left has a 2, the fraction on the right needs a 2, so we multiply by 2 over 2. So only the fraction on the right needs to be multiplied by something. So this becomes 9 over 2 times x minus 2 minus x times 2 is 2x over 2 times x minus 2. When you're multiplying, this is going to the whole other denominator. And so now we just have 9 minus 2x over 2 times x minus 2. And again, those 2's don't cancel out. Okay, they would cancel, and I'll do it up at the top. Let's say we had 2 times x minus 2 over 2 times x minus 4. They would cancel here because both of them have a 2, or the 2 is being multiplied to both. But in this case, 9, you can't take a 2 out of 9, so it would just stay. Thanks for watching. If you have any additional questions, please feel free to reach out to me.